All right, everybody. Thank you for joining us today. We are trying to figure out our slides here. So bear with us for a moment while we continue to struggle with this a little bit. We might have to have our slides next to us. Can anybody let us know exactly what you're seeing on the slides on the show? Because for us, it might look a little different. In the chat, are you able to see the full screen of the presentation?
I'm posting something in the chat to see if people
Okay.
can you
All
post
right.
in the chat?
Yes, you can. All right. We do have a whole list of people here. Oh, no, you're not seeing the full presentation. All right. We are trying to figure this out in GoToWebinar, so sorry, everybody. Um,
Yeah, it doesn't
I
want to
don't,
seem to share presentation mode.
yeah, it's not sharing presentation mode. I'm going to try to share that right now. If anybody has any tips in GoToWebinar, um, that would be fabulous. Um, I'm going to try one more time here. I am actually just going to go to sharing. Uh, Maybe try this. And Emily, this might mean that you might need to go. Uh, I'm just going to try this and play from beginning. Did that do anything?
Yes,
Full screen?
full screen.
Is everybody else be able to see the full screen as well?
I'm getting thumbs up from the chat. So,
Okay. I cannot see anybody any longer. So, Emily, I'm going to have to take guidance from you.
great.
Uh, all right. All right. Thank you, everybody, for your patience. Sorry to waste 3 minutes because we do have a full deck of information here today, which we feel is really important. But again, thank you for joining us for Designing Healthy Homes Strategies for Client Conversations on Indoor Air Quality. This presentation does qualify for one HSW credit. So please make sure to email me with your AIA information and I will file those and make sure that you get a certificate. Here's our AIA disclaimers, copyright information. And all right, so Emily, why don't you go ahead and introduce yourself and I'll go from there.
Hi, everyone. I'm Emily Mottram. I am an architect in Maine. We primarily do residential construction. My personal passion has been building science from the beginning. And for me, that also really includes indoor air quality. So I've known Nikki for a number of years now, and this is something that we're both really passionate about. And we think a lot of other architects and people in the industry should learn more about it.
All right. My name is Nikki Krueger. I've been in the indoor air quality industry for 20 plus years. Everything from adding humidity, taking out humidity, air filtration, ventilation, controls. The last 15 plus years have been specifically on dehumidification, ventilation, and air filtration. I'm very passionate about the topic, and I appreciate everybody being here today. So today we're going to cover the importance of indoor air quality, framing IAQ and and client conversations, building science for IAQ, case study, and tools and resources. And hopefully we'll have some time for Q&A. Emily and I both have time after. So if we get to the point where we're at our hour mark, we're happy to stay on. So the importance of indoor air quality, we spend 90% of our time indoors. We've all heard this statistic over and over again. We breathe about 3,000 gallons of air a day. Adults, 16 breaths per minute. Newborns, 30 to 60 per minute. Toddlers, 20 to 30. But the average person breathes approximately 13 million cubic feet of air during their lifetime. This is why the air quality in our home is so important. Um, so there's a lot of common pollutants that are in our homes. They come from all different uh, places. We have excess moisture and humidity. Obviously, mold is always a big concern. I talk more and more to architects, engineers, home builders, homeowners, especially that have sensitivities to molds. We have odors and asthma triggers. And a lot of times these are coming from our crawl spaces, basements, poor ventilation. Of course, the occupants are going to generate moisture, and air leakage is a big part of where that excess humidity and moisture is coming up from. So particulate matter, asthma and allergies, we know that asthma and allergies are on the rise. And trying to prevent that from coming in our homes is really important. As architects, you are trying to, look at this stuff from the beginning. Obviously, if people are bringing pets in their home, we can't control that, but there are things that we can do to try to help minimize the buildup of pet odors and obviously allergens. VOCs, volatile organic compounds, more and more. What we're building our homes with and what we're bringing into our homes um, can cause issues for people who are sensitive, and that can cause headaches and nausea, long-term exposure. But we really have to think about the materials that are in our homes. Poor ventilation, um, this is going to help us with those pollutants and odors, and something that we really need to be thinking about on those early at that early design stage. Carbon monoxide, again, that's stuff that we're potentially bringing into our homes, building our homes with, and homeowners really need to be educated on choices they're making, especially if they are concerned about the indoor air quality in their home. Radon, we're not going to dive deep in. That is very specific to different areas in the country, but you need to be aware of radon. It is the number one cause of lung cancer after smoking, and we need to be able to make sure that when we're building our homes and designing these homes, that we're thinking about the potential for radon and what area we are in. And then biological contaminants. This is where, if we're not thinking about, or if we start having issues, especially in if we're renovating homes, where do we have standing water? Where are we not getting proper drainage? Maybe not good ventilation, maybe not good dehumidification, but a lot of times this is going to include mold, bacteria, and pests. So health impacts from poor indoor air quality. Indoor air quality has been ranked among top 5 environmental risks by the EPA. 50% of illnesses are caused or aggravated by indoor air pollution. 1 in 5 people have either allergies or asthma. 200% higher allergen rate levels in super insulated home as compared with ordinary homes. And 6 out of 10 homes are hazardous to their occupants' health. Um, these are some pretty powerful statistics, and there's no doubt, working either you're designing a home, or if you're a builder on this presentation that's building homes, more and more people are very aware how indoor air quality affects someone in their home or them personally. So I'm sure you're all getting more and more questions about the indoor air quality and what they can do in their homes. So, framing indoor air quality in silent conversations. Um, Emily, do you want to go ahead and take this part?
Yeah, I'm not sure if I can advance the slides, but I can see everybody's
Sure.
comments in the questions. I'm not sure why the chat box isn't working, but post your questions in the question section. So Framing indoor air quality for client conversations for us has a lot to do about not using industry jargon as well. So, like, why these early conversations matter. So, understanding their health and their lifestyle. We have clients who come to us who might have allergies, who have multiple chemical sensitivities after mold exposure, have missed a lot of work, and are moving, trying to find a healthier house. So, we ask a lot of questions about their health and their lifestyle. We ask about their past experience, past houses that they've lived in. We present IAQ and health as a comfort and a benefit. So we talk about that from the very beginning. In fact, for all of our new construction projects, ventilation and dehumidification isn't even something that is non negotiable because we find that it's so important. We're going to get into that. We discuss the solutions and the benefits before diving into the specific products that we might use. Oftentimes they're not interested in the technical stuff. Um, they want to understand how this solves a problem for them, not necessarily the unit. Although I will say that one thing that we do is follow up afterwards, to make sure that they know how to maintain the systems they have. So next, um, health and lifestyle questions. So what does that mean, right? What questions is Emily asking? So do they have family members with asthma, allergy, mold sensitivity, respiratory questions, um, that we need to consider during the design? How much time do they spend indoors or outside? Like, we have homeowners who want to open their windows all the time. So we need to make sure that we understand what that means. Are there specific health or wellness goals that you want to support in your house? Then frame it with the comfort, right? How important is it for you to feel like you have fresh air in the house? Have you ever noticed issues like, is it stuffy? Does it have odors? We will talk to our clients about how much they cook, right? So if you notice that it still smells like what you cooked for dinner the following day, like, those are questions that we want to have. And would you like a house that minimizes dust or allergens, that has easier to maintain? Because building tighter homes isn't just about, um, having better ventilation. It's also about dust management, pest management. Sustainability, right? Are you interested in eco-friendly or health-focused features like non-toxic materials? We have people who come to us who say, I want to make sure it's formaldehyde-free. Or if you've ever met Caroline Blazowski, the healthy home expert, she says if it has a smell, it can have a reaction for people. So also, some of the things that we don't think of as toxic could be a problem for other people. How do you feel about investing in your systems? Again, oftentimes these ventilation systems that Nikki and I are talking about are less than 1% of the cost of construction, right? We're not talking about a lot of money, but we are talking about a lot of value. And have you heard about certifications? And the reason we bring up certifications is that third party testing means that it got installed, but it also is operating the way that it was installed. So, education and framing those questions. Did you know that indoor air can be more polluted than outside air? We're going to talk a little bit about that. I don't know if anybody's seeing the indoor air quality indexes for the areas they live in, especially if you're anywhere near wildfire prone areas. We had a spike on our monitor here. PM 2.5 was high. We thought it was because we were doing demo in our basement. Turns out the outside air quality was actually worse, and our ERV was bringing that into the house. Um, would it be helpful if you designed your home to reduce exposures to things like chemicals, mold? And are you familiar with ventilation systems that can, do people know what a ventilation system even is? What does that mean? Why is this critical? Okay, so why are we having these conversations? For me, that's partially because there's no governing body that certifies what materials we put in our house. You can literally put so many toxic things in your house without understanding because it's just part of the typical build process. The better we get at air tightness and thermal enclosures, the less good our buildings at resisting the poor choices that we make. We want to be making good building science decisions, making tighter buildings. But once we do that, we introduce them to other issues. A small mistake can have large implications in better buildings. And we're starting to associate those things with poor health outcomes. So, building science, for those of you who have heard of me or know who I am, I'm super into this building science nerdiness, right? So, how do we understand what's happening in our buildings? If we have, you know, flow from inside to outside, from hot to cold, that temperature difference, is it indirect like infiltration? Is it coming through, your soffit, the leaky structure? Is it mechanically caused? So you causing negative pressure when you turn on your dryer or your range vent hood? So what's happening in your house? Because all of these things are connected. And here's another kind of quick demonstration. I show this oftentimes with my students is our leaky old homes. Several of the toxins were non-issue. If you live anywhere in a radon state, if you had a really leaky old house, so Maine has a lot of the oldest housing stock in the country, was radon wasn't an issue because it was so leaky. It just had a lot of extra air infiltration. So it wasn't an issue because of that. Studies have also been done to prove that they're not related to um, the health outcomes of the homeowners or new building products on the market inherently change the dynamics of our structure, right? So you're like, okay, I have this old house and I'm going to make it tighter. Well, now you've trapped radon inside. And I'm using radon because that's big for me, but also we're going to talk about carbon monoxide and other things. I like this diagram too because it feels really obvious that it's going to draw it in from the bottom and it's going to blow it out through the top. This is fairly common. So this is why when you hear people, I often say boot and hats, right? That's what you wear in the wintertime is your boots and your hats. So really addressing the top and bottom of your structure is going to make a big difference, bigger than replacing your windows. But
And
this,
then, oh,
go
I'm
ahead.
sorry. And this would be the reverse if you're in a hot, humid climate, right? During the
Correct.
summertime, all the pressures are coming into the house and trying to get in. Where in the wintertime, you got a hot air balloon, and it's all trying to rise and get out of the house and sucking in from more below.
Right. So, what do we need to know? One, your house is a system. If you change something, that has an impact on something else, whether you can see that immediately or not. All of the parts are interrelated. So, if you make it tighter, that's going to trap moisture inside, or it is going to change your building's ability to resist performance. If you add more insulation, you could have condensation in your walls that you didn't have before. So you need to know what you're asking your building to do because they're related. You need to inspire your clients to be interested in their own health outcomes. A lot of new clients think that building a new home means they're getting all of this just because, and that's not really the case. And then challenging one thing or changing one thing can seem insignificant, right? Oh, I'm just doing this one thing, but it could have a major impact on the structure and on the occupants. So, occupant health is also very often tied to the structure health. So, airtight construction and controlled airflow. Um, so, I think this is still my slide, right, Nikki?
Yep, yep, yep.
Okay, so in practice, what we're going to do is continuous air barriers. If you've ever seen Steve Basic do the red pen test online, you want to have them continuous. They need to touch every single thing. That's high quality air sealing with caulking, with taping, blower door testing, because how do you know how well you did if you didn't test to look for it? And creating an airtight envelope while integrating all of your controlled ventilation because once you make it tight, you need to provide fresh air for your occupants within the space. And then the impact on the indoor air quality is it minimizes uncontrolled infiltration from outdoor pollutants, dust and pollen, and prevents indoor pollutant buildup by directing airflow through those filtration systems. And I'll add to that, it also puts the ventilation where you want it to be. So, how do we talk to our clients about that as we explain how a tight home with smart ventilation improves both their health and their comfort. This keeps dust and pollen out while bringing filtered fresh air specifically to where you want it. You exhaust it from places like bathrooms and kitchens, and you supply it to your bedroom where you sleep all night long. I love Infrared photos. So, for those of you who haven't seen an infrared photo before, the photo on the left, for me, because this is a cold climate, is showing cold. So, above those light fixtures, which are basically just a whole bunch of tiny chimneys into the attic, you'll see a lot of air infiltration around there. It's also possible no one laid the insulation back down after they put this electrical in. So, you're seeing really cold spots. Those leaky structures don't provide air where you need it. They provide air wherever it's leaking. And above my dining room table is probably not the place that I want it. And I definitely don't want to breathe in the stuff that's in my attic. We also talked briefly about materials. I know materials can be super hard, and if you don't have a degree in chemical engineering, it can be really hard to tell whether or not the stuff that's in your materials is really bad, moderately bad, kind of okay. This is what we do. We specify things that are low or zero VOCs where we can. That's adhesives, paints, sealants, finishes, as well as non-toxic materials like solid wood over your particle boards, anything that has to be kind of glued together, particle boards, plywood. We're going to reduce off-gassing of harmful chemicals that can cause respiratory irritation or long-term health issues. And then our tip that we do with our clients is frame it as health and aesthetics win-win. We can choose something that looks nice, that is non-toxic, and keeps it healthier and safer. I put the Declare album up here. So for Living Building Challenge, you can look at the red list if you understand what all of those chemicals are. If you're not sure if something's on the red list, the Declare page is also helping brands that have materials for sale add their things on there where they've done a little bit of the legwork for you. You can also look for environmental product data sheets. More and more manufacturers are getting into that. VOCs, not all VOCs are a major health hazard. Some are, like formaldehyde, so you don't want products with added urea formaldehyde, but it's naturally occurring, and depending on how hot it is when they dry your wood, you may actually increase the formaldehyde in just typical wood. Many petroleum-based products have plasticizers in it. So essentially think of it, if it's flexible or easily spreadable, it has something in it that takes it from hard plastic to easier to use plastic. Spray foams, if you got to wear a hazmat suit to install it, you want to think about what it's made of and how well it's chemically mixed and its chances of continuing to off-gas. And in the US, just because we don't have anything that regulates that, it's up to us to make a list internally as part of your practice to be the guardians of our bodies and our clients' healths. Source control and pollutants. I say this on every webinar I think I've ever been in. If you hear nothing else from me, please, please, please put in a range vent hood. I think that our friend told us that you should use it when you use your toaster as well. Practice is to design to minimize indoor pollutant sources, such as specifying electric or induction over gas. The tighter we build our homes, the scarier gas ranges are, and ensure proper ventilation for kitchens and bathrooms. Eliminate or reduce harmful emissions at the source by preventing IAQ degradation, and position as health and safety features such as induction cooking is not only modern, but it also cuts down on indoor pollutants. And a lot of home chefs actually really like induction because it can be fine-tuned. Carbon monoxide. I feel like, did I take some of your slides, Nikki? I feel like I've been talking for a while.
I think the first section, but I threw it over to you, but no big deal.
Carbon monoxide. Anyway, sorry. Carbon monoxide is tasteless, colorless, and odorless. This is another reason why gas ranges inside tight houses are a problem, because you won't necessarily know if you have a problem. It's created by heating systems, water heaters, wood stoves, gas ranges, and fireplaces, unvented gas or propane heaters, and generators. So we want to be paying attention to the things that we could have in our house. There are carbon monoxide alarms that you can have in. You want to have a low level carbon monoxide alarm, not just the ones that are all readily available on the market. And pets, right? So pet dander comes from skin cells shed by your animals. Unlike cockroaches and dust mites that kind of land on your carpets and your bedding and material, pet dander has a tendency to stay in the air longer. So if you have clients who have trouble because they have pets, this is something to pay attention to. But it also does stick to furniture and fabric. So paying attention to that by having healthy indoor air quality is great.
Well, and I think everything, you kind of covered. A lot of choices come with design and conversations that you can talk about, not having a gas stove versus an induction, but a lot of times pets are a non-negotiable no matter what. And they don't understand, a lot of homeowners, especially going from a leaky home to a tight home, don't really understand that once you get into a higher performance, tighter home, um, maybe you didn't have any health issues around your animal or your pet. Maybe you didn't smell them as much in a leaky home, but now that moving into more of a high performance home, things are going to change. And so understanding that ventilation probably needs to move up even a little bit higher on the list of those talks when we talk about having pets in the home. So I'm going to talk about here more into the next conversations that we need to have with homeowners. And a lot of these are going to evolve around this HVAC system and why it is so important that architects and homeowners have clear expectations of this system in the house, because a lot of times we just think about it as heating and cooling, but really these systems provide comfort, provide the health, provide the property protection, and we want to do it with the lowest energy bills as possible. And so I cannot stress enough the importance of getting your mechanical designers, your HVAC contractors on board very early in these conversations, because they need to understand clearly what the expectations are um, of the homeowner and what you are doing to design these homes and to build these homes, because it is going to affect all of these things um, for the homeowner. So, what are we trying to achieve? Heat, cool, dehumidify, humidify, purify, ventilate, and every room 24/7, 365, and as energy efficiently as possible. I mean, this is a huge ask um, of what we typically call one system, the HVAC system. So clear expectations and how we're going to do this early on is super important. So moisture and mold prevention, obviously, mitigating standing water first and foremost. That is, we got to get our waterproofing. We got to get those details, vapor barriers, airtight construction, all of those things we've got to get right as much as possible from the get-go. I talk to a lot of homeowners, a lot of HVAC contractors after a house is built, and I am never going to just say, okay, here's what you need to do when they call and tell me they have a moisture issue. I'm going to ask a lot of questions. Have you had a blower door number, or do we have a blower door number? Do we know where our leaks are? Can we get to those if possible? We got to try to make that envelope as tight as possible as we can. In existing construction, that's very challenging, but never do we just want to throw a piece of equipment at a problem without understanding as much as possible the bigger picture. So, do we have a right sized HVAC system? Newer construction, hopefully we're getting that. And then we start talking about, okay, can we talk about a dehumidification system and how that's going to work? But we never want to throw that first, because we got to make sure it's going to be successful. And ideally, in the humid season, spring, summer, fall, we want 50%, not 30%. 30% would be during the winter time, but 50% from an indoor air quality standpoint is where we want to be in the humid season, and that 30 would be in the winter time. So, obviously the ultimate goal is is to prevent mold and mildew. Um, but the reality is we have wetting and drying times of the year, and typically leakier homes didn't have as much mold and mildew issues because they would wet and dry and wet and dry. But now that we're having hot, tighter homes, we seem to be wetting a lot more. We've reduced the AC runtime because that's the goal, reducing the runtime of the largest system in the house as much as possible. But that was our drying solution, was that longer AC run times provided more drying. Leakier houses provided more drying when it was drier outside. And now we don't have that as much. So we need to think about that. So, we really need to understand our clients' concerns. And, this affects sustainability of the home as well and comfort. So really understanding and talking about past experiences in other homes will help them understand this more. Homeowners are all about really energy efficient HVAC systems, but sometimes they don't understand the consequences of less air conditioning runtime. So here's it's called the Sterling chart. But here is where we can see that 50% relative humidity is optimal for a lot of indoor air harmful contaminants, bacteria, viruses, fungi, dust mites. Dust mites go dormant, I think, below 55% RH. So you get to that 50%, and 85% of people that have indoor allergies, it's due to dust mites. So once you make them go dormant, then that will greatly help with their health in their homes. But respiratory infections, and then you get into the sometimes it can be too low during those winter times. And depending what kind of house you have, you may need to add a little bit more humidity. Typically not in new construction, at least for the first 3 years as materials dry. Even in heating dominated climates, especially with a tighter home. But we don't want to go too high either. So 50 really is for health. So off gassing, most people don't know that the higher the relative humidity in the home, the quicker and at higher rates that the materials that you bring into the home are going to off gas. So if you've ever heard of Chinese drywall that was happening down in Florida, there was a large amount of off-gassing happening to this Chinese drywall, which was causing formicary corrosion on the HVAC systems. And that Chinese drywall actually made it farther north, but they can't find it. And one of the reasons is because they didn't have the high humidity levels for long enough in order for it to off gas and cause the issues. But yes, chemicals are going to come from the materials in the home at higher rates with higher humidity. So Manual J is our bullseye for your HVAC contractor for sizing that HVAC system. So for cooling, it's going to be 75 degrees and 50% relative humidity. So our goal has to think about, okay, they're designing this system in order to run at peak heating and cooling temperatures. And most of the time, our systems will run 1% of those peak times. So we size and design a system based on 1% of the year. So how are we going to control that relative humidity at 50% when we're not running at that peak July 4th load that it was designed for? So one of the things that also affects how that AC system is going to manage the moisture when it is running is the sensible heat factor of that system. So SHF is the sensible heat factor. And basically what this tells us is how good does that AC system work at dehumidifying or removing water when it's running? And what we typically see is the higher the SEER, which the SEER is how energy efficient that system is, the higher the sensible heat factor, meaning that it removes less water. So what does that mean? Let's look at some data here from an HVAC manufacturer. We have a 14.5 SEER system here, and its sensible heat factor is 0.62. What this means is that when it's running, 62% of the BTUs from that system are going to the sensible cooling, so the thermostat setting, what you feel, and 38% of the BTUs are going to remove water. So when this system's running for an extended period of time, it's doing a really good job of dehumidifying when it's running. Here we've got a half-ton ductless mini split with a SEER of 33, really energy efficient. But when it's running, 96% of the BTUs are going to the sensible, what you feel, and 4% are going to water removal. So, that's why most of the condensate lines on a ductless mini splitter are like the size of a pencil, right? I mean, they're really good at getting to a temperature quickly in a small space. And you're not getting a lot of runtime even when it is running because of the smaller space. So understanding this and being able to have conversations with your clients early on, so they understand these sort of things, because we can get wrapped up in tax credits and energy efficiency, but ultimately you need to understand the outcome. And maybe it is we go super energy efficient with the AC system, but we want to make sure that we might have to size a bigger dehumidifier in order to manage the latent or moisture load that the AC can't handle. And then variable capacity equipment. More and more, we are seeing these systems higher end that they can reduce the fan speed quite a bit. They can run longer. They market that they can control humidity better. But the reality is they're not getting as cold for that supply air temp as more traditional, potentially two-stage, even single-stage equipment. Um, they're not removing as much water, ultimately, because 2/3 of the BTUs are still going to cooling, and 1/3 is going to removing water. So ultimately, they could be removing even less water. Brian Orr, if you're not familiar with him with HVAC School, I've done several podcasts and presentations with Brian, and he really goes into this. We actually, I wrote an article in Fine Home Building or Green Building Advisor a couple years ago. And Brian and I kind of talked about this in the article a little bit, but really understanding the marketing of HVAC systems and the reality of how they're performing is really important. And no matter what, you still have to have an air conditioning load for this to even be running and removing any moisture. So the tighter the house we build, typically the less AC runtime. And even with that, when it hits that thermostat set point, it's going to keep that house conditioned to that set point for a longer period of time. So we can't count on our air conditioners, even right sized, to remove the moisture that we need to be at a healthy level, a healthy and comfortable level in the home. So whole house ventilating dehumidifiers. The company that I've worked for the last 15 years, we invented these. A gentleman named Ken Gehring, who's 84 years old, and he's on a forum called HVAC Talk, very old school forum. He, I think last I checked, had 12,000 posts on there, and architects, engineers, HVAC contractors, homeowners, they often go to him and say, we've got a moisture issue. And the great thing about Ken, And on there, he's going to be known as Teddy Bear. So you'll have to look for him as Teddy Bear. But he's the first one to tell you when a dehumidifier isn't going to fix the situation. And a lot of times he's going to talk about understanding what the envelope, what's going on with the envelope and what's going on with the HVAC system. But a whole house ventilating dehumidifier is designed um, to basically dehumidify the entire home, separate of AC runtime. You can bring in outdoor air if you want to do a slight uh, positive pressure or supply ventilation um, through that dehumidifier. Then also we've got a MERV 13 filter in all of our systems. So the air conditioner can run based on thermostat. Of course, we want it rise size. As Ken would say, AC is king, dehumidification is queen. When the AC is sleeping, that's when the queen, the dehumidification really shines, and especially those shoulder season and overnight times. A lot of times overnight, people get up and crank down a thermostat. It's not because it's a temperature thing. It's typically because it's a moisture thing. And we also want to make sure that we're controlling moisture below the house. We don't want to have ventilated crawl spaces. We want to make sure that space below the home, crawl space, is within our envelope. We're treating it as part of the house. Advanced Energy has done studies out there about how much more humid a vented crawl space in. And the most important thing is you got to remember and explain to your clients that 50%, up to 50% of the air that's below the home is going to make its way into the living space. And, if you're working on renovations and you're going to homes that have vented crawl spaces, I can guarantee you that most of those homeowners will not go into that crawl space. They're not that is not the air that you want making its way into the living space. So it's very, very important that those spaces below the home are actually addressed as well. And code allows for doing some supply air from the ductwork in order to condition that space. If you want to talk more about crawl spaces, please reach out. But providing a little cold, dried air into a space below ground is not controlling humidity, and that's really all you want to do is control the humidity. All right, Emily, back to you.
So this is a great segue because someone in the question, when we'll definitely answer this, asked if putting in a ventilated dehumidifier negates the need for an ERV, and I would say
Mm-hmm.
my favorite thing is it depends. So we'll definitely talk about that and answer that question. And I super appreciate that Nikki talked about the shoulder seasons because here in Maine. We're not running our air conditioning this time of year. It's June 10th. I think it's like 50 degrees, and this is like the 83rd day of rain we've had this season. So um, I think I'm going to turn my heat on, which is crazy in June. But the one thing that we do have is a ventilation system. And so optimizing those ventilation systems. So for us, I think dehumidification plus ventilation is really important because in the wintertime, we need the ERV because we need to keep as much moisture in as possible in these cold climates. And I know Nikki can talk about living in Wisconsin as well. But optimizing your ventilation system is design and installed balanced mechanical systems such as your ERVs or your HRVs, depending on where you are in the country, and provide fresh and consistent air while maintaining energy efficiency. We often get asked, what's the cost of, running ventilation? That's significantly less than the cost of your health. The impact on indoor air quality is it ensures adequate air exchange to dilute the indoor pollutants, whatever they might be, and maintain oxygen levels, reducing stuffiness, health risks. If you work from home, reducing the CO2 in the office, like everybody who has that slump after lunch in their home office, and highlight with our clients how ERVs and HRVs deliver fresh air without sacrificing the energy costs and addressing comfort and health concerns such as allergies, asthma, sleeping better at night. So many things that are so important about ventilation being to the places that you want it to be and to be balanced, which I'm not sure if we have a slide on here, but having somebody check to make sure that none of those ducts are kinked and you're actually getting the ventilation, either exhaust or supply, to where you want it to be is critically important.
And I think balanced is, an interesting conversation to have, because what balanced ventilation means is that that ductwork is balanced. The air, those fans going in and out is balanced. It's not that the house is balanced. You got to remember that you've got exhaust from a kitchen hood, exhaust from your clothes dryer, exhaust from a bathroom. And depending how what you use for ERV strategies for those, but typically homes are going to be underneath negative pressure. You're just providing whatever you're exhausting makeup air uh, for. That's what's balanced in a humid or mixed humid climate. Even with an ERV, you're typically going to want to set those that you're bringing in more outdoor air than you are exhausting, to try to get a slight positive pressure if possible in that house. Now, a ventilating dehumidifier is supply only, and that's typically because houses are a lot of times underneath exhaust. And if it's not a, high, fierce passive house kind of level of construction, you typically are going to be a little bit more negative and positive. So we can do that supply positive pressure. If a homeowner can't afford to, typically I would recommend in a mixed humid to a humid climate to always go with the ventilating dehumidifier. You don't have to use the ventilation. So if you want to keep them separate, a colleague of mine, David Treelevin, wrote an article in Green Building Advisor several years ago on how to integrate ERVs and DHUs into designs, and the pros and cons of the options. But ultimately, keeping them separate is always what you want to do. Just let the ERV provide the outdoor air, and let the dehumidifier dehumidify the house. But again, if you can't afford both, then going with the ventilating dehumidifier is probably the way to go. All right.
Again, we can't ventilate our poor choices. Unfortunately, there isn't enough ventilation to offset the poor product choices that are available through the building industry. So this is another reason why we want you to both pay attention to what's happening with the indoor air quality and then ventilate or dilute what we can't get rid of. So you look at this and say outside air isn't just outside air. Um, right now with the wildfire smoke. So we have the difference between outside air, which is whatever it is outside in this hazy picture is not so great. You have your infiltration of your building. That's this nasty outside air running through your insulation, through that crawl space that Nikki just talked about, through, and she said she asked people who's been in their crawl spaces. I also asked people who's been in their attic, and the chances are like pretty slim to none. And so they're like, oh, that's gross. Or there's, maybe you live in a place where there's bats and there's bat droppings. Well, I don't want to breathe that. And then you have filtered air, which is taking this and running it through some kind of filtration system. And that's what we would consider the most fresh air. So this is a picture of an ERV core outside, wildfire smoke kind of coming in here. It's actually wood wood stove smoke from someone who didn't burn either dry wood or didn't make hot enough fires. Destroys the core of your ERV, destroys the filters in your system, but also, well, we weren't breathing that, which is kind of nice. If the window was open or we just had infiltration into the house, we would be breathing that air in. So outside air, again, is the outside stuff, right? Where are you bringing it in? Where is it going to? Air leakage is through the structure. And as architects, hopefully we've kind of learned a little bit about typically the places where the air leaks are usually the least likely. Like the air leaks aren't always coming through your windows. They're coming from the basement. They're coming from the band joist or box sill. That's one of the leakiest places in our structure. So they're coming from below the structure. They're coming through every chimney that we put into the attic, especially in those hot, humid climates, attaching to whatever the insulation is and coming inside. So this is just sort of a diagram of like which rooms are negative, which rooms might be positive, where's the air leaking inside and outside. And it's not necessarily where you want it to be. Carbon dioxide, we put this on here, and part of the reason why I talk about it is carbon dioxide can create poor sleep. It can make you sleepy and tired. It can give you headaches. It's not sort of the super dangerous thing that carbon monoxide is, but it's one of the easiest things to monitor. So when you're just getting a client into this, we're talking temperature, humidity, and carbon dioxide, which are three really easy places to start and get them interested in their health outcomes, and usually a really obvious um, improvement on that. If you say, man, I'm tired today, and look at the carbon dioxide in your living room or your bedroom from last night, then it's like, oh, okay, well, maybe I needed some more ventilation. So this one's a really easy to talk to your clients about because it's easy to monitor and it's easy to kind of understand. ASHRAE 62.2, we put this on here because if you're new to ventilation or ventilation standards, this is a great place to start. This is a minimum ventilation standard. So this is kind of the minimum for what we would want to be starting with for our clients, depending on their comfort level or their health outcomes or how tight their structure is towards passive house, etc. You may need to modify this ventilation, but this is the minimum amount we want to have. And I don't know about you, but in our cold climates, having a window in your bathroom is not ventilation. I'm not opening that when it's 15 degrees outside. So I'm not getting rid of any of that moisture either. So having windows isn't the best ventilation strategy. So this ASHRAE 62.2 helps you to kind of understand what you should be providing at a minimum level for all of your clients.
So next we have high efficiency air filtration, which is really important. We want to make sure that not only are we filtering the air in order to keep our HVAC system clean, but we're also filtering the air that is going through the house when the system's running. And I know a lot of people put on these high efficiency air filtration systems, um, and then they want to run the fan continuously, which makes sense, right? Like, we're going to put this in, we want airflow through the house all the time. But the reality is if you do this during the humid seasons, you are actually going to be making your homes more humid because running that fan is going to be evaporating the water off the coils on your AC system back into the living area, the living space. So you got to be careful with the strategy on using these. You want it to filter when the system's running, and maybe in the wintertime months where you're running the heat and you're getting a lot of, you want to use that airflow to make sure that your rooms are balanced with the same temperatures, but that cannot be a strategy during the humid months unless for sure they're going to have a dehumidification system that can help mitigate that excess moisture that's coming from those coils that build up. And that can be, there's about a pint or a pound of moisture, of water on those coils per ton. So you have a 3-ton system, you got 3 pints of water on those coils. When the system shuts off, that fan's running, that's evaporating all back into the living space. So highly recommend high efficiency air filtration, but you got to be careful on how you use it. It does, it only removes what makes its way into the ductwork as well. So I always have told people that when they're vacuuming, make sure the system is on, because whatever you're stirring up, hopefully it's making its way to that filter. But again, it's only going to collect what is making its way into the ductwork. Um, and there's a lot of great filters out there. There's a lot of proven benefits to having high efficiency filters. But these are decisions that have to be decided early on with the design of that HVAC system, because they are going to add static pressure to that system. So you can't, it's hard to do an afterthought. So having that conversation up front is very important. And the higher the MERV rating, which is the minimum efficiency rating for that filter, the more that it's going to collect. So having, like, we have MERV 13 filters in all of our dehumidifiers, because a lot of times they're used for ventilation. Even if that MERV 13 is in a crawl space below, at least it's collecting stuff down there that isn't going to make its way up. But the higher that MERV, now you usually can't go much higher. There are some MERV 16, there's combo electronic air cleaners with filters. So a lot of options out there, but just make sure that you understand what it is, its capabilities are. So back to you, Emily.
So, the key to indoor air quality success, right? So, engage an indoor air quality specialist, or if this is you, right? Some of us get super nerdy and into the weeds, and we spend time with people who are smarter than us. Bring on mechanical engineers and HVAC professionals during the design phase, right? This is something we get dinged on as architects. We never give them enough room in their mechanical space, but it's also critically important for us to understand how these units go together. We've already said once today, like it depends what your strategy is going to be. So having that in place and being able to talk to people who say this is the most cost effective way to meet all of your needs in here. So HVAC, IAQ, duct design, this is important. It is part of the tripod of having everything done at the same time, the client, the builder, and the design professionals. And the design professionals do include all of your HVAC consultants. Material and equipment reviews, because you want to install something that can also be maintained and that you can get support on. Installation protocols so that you know that they're installing it correctly. Commissioning and performance testing, this one's critical for me. Part of the reason why ERVs weren't so widely adopted in our market for a long time is because nobody came to check whether or not they were installed correctly, and a lot of them were not, and they were creating more issues than they solved. Maintenance schedules. I saw somebody asked in the chat about mold, and so I think it's important to talk about maintenance schedules and that nothing is zero maintenance. And so sometimes you have to do maintenance schedules to make sure that you are keeping up with that. And indoor air quality monitoring, so the types of monitors that we're going to use. Just real quick, I'm going to fly through this because we've got like 3 minutes and a lot of great questions. So if you can hang on, that would be great. So everyone asks, well, what did you do? This is client facing. So this was a particular client that we had. They had multiple chemical sensitivities after living over a bus station for several years. What was important to the client? They were diagnosed and they knew they had a petroleum allergy. So we were very specifically looking to remove petroleum and VOCs in this project. She also was adversely affected by mold, and it was critically important. So she wanted no basement because she was very concerned about having a basement. Unfortunately, the lot that she picked, that she stood on and counted how many cars drove past, and it was like one car in an hour and a half. So she decided that was okay. She literally did that on every site she looked at. We put in a basement because that was what the site really needed, and we made sure we insulated it, conditioned it, and put in dehumidification. And then before purchasing this piece of land, again, she went back and looked at how many cars went past because petroleum was a major issue for her. Here are the drawings. I put this in here because you guys are architects, and one of the things I want to say is what she had to give up on was space to get the things that she needed. So this conversation with our clients is critically important when you're talking about health outcomes, and they often will come around to what you need to do. This house was basically 1,100 square feet. It has 3 bedrooms and 2 bathrooms. Shockingly, a lot of space, and we did a lot with air sealing to make sure that this was as tight as possible. And we did a lot with insulation so that we could cut down on the mechanical systems that she needed because we couldn't use anything petroleum based. And what we learned was we wanted to eliminate the toxins, ventilate what we couldn't. So we have an ERV in this as well, and then dehumidify because she had major concerns about moisture. And this was a super tight house. So we wanted to make sure that we didn't hold that moisture inside. Go ahead. And then what was important was what was in the materials. And I say this because what I said was, I'm going to send you a box of trash, which she thought was funny, but essentially it was just a bunch of job site materials. And we sent it to her, and it's hard to test things. And I said, take these materials and get in your car because the air quality is absolutely horrible in your car. So get in your car, drive around with this. This will help you see if you have any reaction. So we tested a lot of materials with her that way, that it was vital that the homeowner knew how to operate it. I did a walkthrough after she moved in, make sure she knew how to change the filters in the ERV, clean the filters in the heating system, check the dehumidifier, and operate the systems. And she actually called me right afterwards because we had this conversation and said, no matter what I do, I can't get rid of the moisture in the bathroom where our laundry is. And I said, do you also have dust in there? And she said, yes. And I said, your dryer vent is disconnected. And for somebody who had multiple chemical sensitivities, the heated byproducts of laundry detergent was really a massive issue for her, not just for humidity. And so we were able to catch something that would have been a very big problem for her because we had these conversations after she moved in, and that the right team makes the difference. She talked to every subcontractor beforehand to make sure that there wasn't just a standard way of construction, that it was going to be the best method of construction for her property. So we used soy-based release agents. We got all of our wood unfinished, and thankfully she's not allergic to pine because it smelled like Christmas in this house, but that is an allergen for some people.
We're going to kind of skip over the tools and resources, but if you have any questions, a lot of indoor air quality monitors, infrared cameras, obviously doing blower door is really important. But if you have more questions about these, just reach out to Emily or I, and we're happy to discuss these more with you. Um, Obviously, addressing challenges, a lot of common problem budget limitations, but like Emily talked about, I mean, knowing these things up front is the the least expensive time to address them. And I'm going through designing a house right now. So, and I'm making changes. And every time I want to make a change, my husband says, this is the least expensive time to make the change. So I understand that as well. But, in balancing indoor air quality with design aesthetics, you might have to put in some more supply registers, return, registers for your ERV, your DHU. I mean, there's going to be things that potentially can contribute. I work on a lot of passive houses where we're doing our in-wall dehumidifier because there isn't any duct work. And, that's a design consideration, but it's got to balance with the indoor air quality. And then obviously understanding the codes and standards, um, making sure that we're following those and how to address those when it comes to the indoor air quality as well. Anything to add to that one, Emily?
Um, Only that, it's really important to understand that the code, the energy code, because that's often what we're pushing for, right? So we're pushing for efficiency. The energy code isn't the only code that dictates what you need to know. And it's really important. And I say this for a lot of architects, you also need to look at the other sections of the code, including the mechanical code and the IRC, which talks about condensation resistance. And so there was a question in the chat box where someone was saying relative humidity is easy for our homeowners to understand. Should we be talking about dew point? And I think that is something that we as architects need to know, but it's really hard to convey, and we definitely don't want to scare our homeowners. So helping them kind of understand how things relate is important.
I agree. That dew point one, believe me, I want a T-shirt that says "Do the do" because to me it's all about dew point. But unfortunately, homeowners do not understand that. I do think there's more and more thermostats and controls out there that are running on dew point in the background, but what the homeowner sees is the RH. Hopefully our ventilation controls get more to dew point, but can talk about that. That's a whole other webinar, which I think we might do this is 101, and I think getting into the next step of really diving deep into some of these things, into the weeds, would be helpful. Start IAQ discussions early. Just to give an idea, I have a homeowner that's down in Florida. They spent their whole life savings on designing this house. They found an HVAC contractor that said they did our dehumidifiers. They had the dehumidifier installed, but it's not performing to what she wants. And every time I talk to her, she's in tears because her husband is got mold sensitivities. She doesn't understand why the dehumidifier is not doing the RH that she expects. I talked to the contractor. The contractor, his first response was, "I knew I should have never taken these clients." And it's just because expectations were not clear. And I tell contractors more and more, work with a mechanical designer that can stamp this and get a team on. And unfortunately, I don't want to have that conversation with the homeowner because that ship has sailed. But expectations and designs have to be an IAQ team early on, especially if you've got homeowners that are sensitive. And they might not even know they're sensitive. They might not bring up, like, oh, and my daughter has asthma, because they think, well, it could be just something outside, and she's got an inhaler. And dive deep into their past experiences, ask questions. Do you remember having a basement that kind of smelled musty? Oh yeah, I remember that. Well, we can address that now. So I think that's really important. um, Emily, anything to add about the takeaways? Because I we can dive into the questions.
Yeah, no, I don't think so.
Okay, I'm just going to put this screen up. Whoops, up here where you can find Emily and I think we can go ahead and tackle, maybe some of those questions. And if not, feel free to email us if we didn't get to yours.
Yeah. So I'm just going to start at the top because it's easier to scroll down. The one first question says, "How do we handle wildfire smoke?" And that's a really great question because that has a lot to do with ventilation, and it goes back to exactly what Nikki said, which is you really need to have a mechanical contractor hired, because if you need to put in higher filtration during wildfire smoke times, you need to make sure that your ventilation system can handle that. So it's either designed that way from the beginning if you know that you are just in a wildfire prone area and it happens every year, or you need to know that for a short period of time you can replace it with higher ventilation in the system, and that you remember to take it back out so it doesn't cause it to work harder and shorten the lifespan of your system. Nikki, do you have anything to add to that?
No, I mean, obviously having a tight a house as possible is going to be key as well. But yeah, and change those filters. After you can shut that ventilation system down, but you're going to have to turn it back on at some point, and run that system, change those filters.
So the next question, which actually popped up afterwards, but I think since we kind of ran past it really quickly at the end, what's the best way to monitor indoor air quality post occupancy, and can it be part of the thermostat? And there are a couple of answers to that question. One, we've been doing this in the commercial world for a long time, so I don't think it's real far off for it to be just much more available residentially. Think Light, I know, is trying to make a residential application from their commercial stuff where they monitor it a lot. I personally, and it was on there, love the Air Things View Plus. For us, that's because it has continuous radon monitoring. So in my climate zone, that's good, but it also does PM 2.5, it does VOCs and other things. And what I would say for that, since we're talking about client education here as well, is what you want to give to them for information is not to get hung up on the numbers so much as take a look at when things spike and start associating those spikes with things that are happening, whether that's you look up the indoor air quality or you look up the air quality index in the area you live. I would have told you that Maine had great air quality and it hasn't really been a thing. And ours spiked the other day. PM 2.5 was really high. Turns out the air quality was not so great in Maine. So similarly, if you have a fireplace and it's this beautiful wood stove and you let it burn down and you don't close the door, you could be having carbon monoxide as that fire dies down. So we've seen that in some of our um, homeowners who have put in a system, and we work with some fabulous mechanical engineers who are monitoring a bigger system, and they associated it with, oh, when you let this fire burn out at night, you're actually getting a lot of carbon monoxide in the house, which is super dangerous. But so yeah, definitely somebody wrote airnow.gov. So those are, and also I believe there was a Haven IAQ, or if any of you follow, I'm going to call you out, Scott Farbman on LinkedIn. He wrote his own fun little program dashboard for a bunch of his different monitors. Those are for like the super nerdy of us. But
There's another one that Sendal, which I don't know if that's the official name for it, but it's Sendal, I think has one, but they have a more consumer friendly name for it. But one thing with RH sensors, um, a, a good, more expensive RH sensor is going to be plus or minus 5% relative humidity. And so if you go to a big box store and just buy, a really expensive hygrometer, those can be off by 10% plus or minus. So homeowners get really caught up in a specific relative humidity, not understanding that that sensor is not, exact, and there's going to be weather patterns that cause it to spike. There's going to be events, a lot of people in the house, in and out. It's going to need some recovery time. But good RH sensors, more expensive, are plus or minus 5%. So, understanding that if you're more in a window, and that's really hard, especially for people who have sensitivities and definitely get focused on the numbers. Um, but but I think, even with us, I think we're with our sensors, are plus or minus 3%. So, I mean, you're talking thousands of dollars if you want to get to ones that are plus or minus 1%. So, really understanding that, there are limitations to all of these sensors, especially at the consumer affordable level.
And I would add to that too is that oftentimes we don't need quite that level, right? So we did a great BSN beer with Dr. Stephanie Taylor, where she talked about things that they monitor in hospitals versus like what we should be doing kind of in our homes. And like there are places where some of those things, that 1% might be super critical. And there are other places in our homes where, maybe that percentage is perfectly fine. Again, that goes back to the filters and filtration systems that Nikki was talking about. Like, do you need a HEPA filter? Most people don't need HEPA filters in their houses, but there could be an instance or scenario, again, back to that conversation. Um,
Exactly.
Nikki, this one is specifically for you. So
Okay.
Ashley asked for clarification. Using a vented dehumidifier would be ill-advised if the home is too tight. What would you say that it would need to be if it was below 1 ACH? Otherwise, do we need a balanced system?
Yeah, I would use an ERV. I would use an ERV for the ventilation, and then I would use, depending on the climate zone, I would use a dehumidifier to dehumidify the house separately. Um, that's pretty tight, and but again, depending on where you're at, you might still want to do a slight positive pressure on that if possible, because as soon as we go negative, we just start sucking everything from the outside in through our walls. And in a mixed humid climate, you potentially then risk the potential of condensation on the inside of our walls. So um, ERV, and then a dehumidifier just to dehumidify separately. The simpler we keep our systems, I know everybody wants the magic box. I want everything in one, and I wanted to do it automatically. The challenge is we really complicate things that way. It's complicated for the contractor to install it. It's complicated for the homeowner to run it. And as soon as one of those things goes wrong, the whole system's down. So keeping them separate and keeping them simple is really the best way to do it.
So then this is also for you, whether you can talk about it or if you want to go to the next question, which is talk about Mystic Mountain Ridge. If you could do everything you wanted to do from scratch, what would you do?
I'm sure we'll be sharing that because Steve Basic and his daughter Lexi and son are designing our house, and we will be working with John Simmelhack, if any of you know him. He is a HVAC designer in Charlottesville, Virginia, that has been very heavily involved in FIAS or passive house. We're not building a certified passive house. My husband's been in the industry for a long time in building science. And so we are going to have an energy efficient house. We're going to be doing some different fun things. So you'll have to follow us on Instagram for that. But yeah, indoor air quality, and believe me, my husband's throwing out some things with dehumidifiers and ERVs that I'm like, oh boy, um, we're gonna have a lab going on here. So, but thank you for asking.
In fairness to everybody, we try all of the things at our own houses
Yes,
first, for sure. When I bought my 1977 house, it had an 8.5 blower door number in it, and I still put in an ERV. Um, we're working towards obviously dropping that number from 8.5 down. Closing in the 2x4 hole in the ceiling was a good start. But next question from Ashley again is I have a lot of clients who are afraid to install dehumidifiers or ERVs because they can become moldy. What are your thoughts on how to prevent mold within each of these systems? And are there methods to watch out for improper installation, or are there better setups than others?
yes. So, maintenance is number one. I mean, all of the
100%
systems,
agree.
maintenance, and change those filters. And if you have someone who's sensitive, I mean, we say 3 to 6 months on ours. Um, if somebody's using ours for ventilation and not just dehumidification, I highly recommend every 3 months changing that filter. Should, if they're sensitive and they're in an area, I mean, there's so many things that, what is going on outside, what are they doing inside, that is going to determine how often those filters are going to need to be changed. Cleaning the condensate lines, just like the HVAC system. um, Making sure that we're, getting longer run times, so not oversizing, and then because that allows us to run for a longer period, and hopefully we have a tighter envelope, and then it allows the unit to shut off for a longer period, and to be able to dry. um, ERVs, the number one thing is filters. I mean, that is going to be what's going to contribute to microbial growth in those systems. So we, just like we live in an environment that mold is around us all the time, we don't want it to be the dangerous molds and to get out of control, but maintenance is going to be key. We have a lot of homeowners that aren't doing ducted systems. They're only doing the ductless mini splits because they don't want the duct work where potentially there could be issues. But that ductless mini split system is going to probably require even more attention, um, in order to be keeping those coils clean and those filters clean. So there's pros and cons and sensitivities to them all, but I think the number one thing is making sure that their maintenance. And the second part, there is a video that I have attached, called the dripping point, that you should be getting a link to, that I did a couple years ago. um, and it is talking about dehumidifiers and installs and doing it correctly, but always making sure that the supply of that dehumidifier is on the supply side of the HVAC system and not going into the return side. And the reason being for that is you're not going to get the dehumidification from your AC system, if you put it on that return side, because we generate heat with a dehumidifier. That heat's going to heat up the coils of the AC system, which means it's going to remove less water. And then when it shuts off and the house needs dehumidified, it's going to blow that moisture back into the living space. So there are tips and tricks to making it more effective and efficient, and hopefully, less potential for issues. So that webinar should be attached to an email after this one is done, that you can. And speaking of that, which I think we're going to wrap this up here, unless Emily, there's other pressing ones.
There's only one more that I
Yep.
might answer, and they're not gonna like the answer to it, but it's what's your favorite cold climate ERV? I saw you have a life breath in one of the pictures, and I would
Mhm.
say my favorite ERV is the one they can afford. I think that's really most important answer, and obviously that they can afford and that is installed correctly. We have probably done one of everything. Uh, we do kind of like, I think it's Brink, Zender, and Panasonic. Maybe some of the other ones do the smaller tubes, which can be very architect friendly if you don't have anywhere to run your ductwork, but can also be very homeowner friendly if you're doing a DIY installation. But the one that you can afford is my answer.
And I love that you said that. Please, please, please give your mechanical systems room in the house. Um, I deal with this all the time. We're going to more back to mid-century modern, so we don't have the attic space. They don't want a mechanical closet. You've got to give your mechanical engineers and contractors the room to put in these systems for them to be successful. Going in afterwards, which is a majority of what I do, to try to find a place to put a dehumidifier is extremely challenging, and ultimately they don't like the look of it after, but there's no choice. So give them the space for these systems ahead of time. um, we've got some PDFs included in the webinar here, one of them being a homeowner IAQ checklist that you can go through with them, and to ask questions. Please let me know if you need credits. Send me an email. I also noticed that I wrote the wrong website on here for Santa Fe. It's Santa Fe, santa-fe-products.com, if you want some more information. But I think that is it. And please reach out to us. And I think hopefully Emily and I will be back for round 2 of this, because it sounds like we can go a little bit deeper
Yeah.
in some of this. So thank you, everybody. We
Thanks for
appreciate
joining.
attending, and have a great day. All right, I'm going to push stop recording.